Hello and welcome to the final ASME design project tutorial. My name is Austin, and in this tutorial you will learn how to connect your mechanical robot arm to your Arduino. Let's get started. For this tutorial you will need 2 joysticks, all 10 of your female to male wires in your kit, 6 of your longest male to male wires, 4 of your medium-sized male to male wires, and 12 smaller male to male wires. You will also need your Arduino, a breadboard, and the wire that comes with your kit to connect the Arduino to your computer. For this tutorial, this will be the wiring diagram we will be using. Feel free to pause the video and try it yourself. Let's begin. To start out, you'll need both of your joysticks, 2 of your shorter wires, a breadboard, and an Arduino. We will first set up our power rail. For this tutorial, 5 volts will be our positive power rail and ground will be the negative power rail. Connect 2 of your smaller wires as shown. Connect the upper positive power line to the positive 5 volt pin. Connect the lower negative power line into the ground. Note that there are 2 ground options and it does not matter which one you connect it to. Next, grab all 10 of your female to male wires. Connect the female ends of the wires to the joystick as shown. It's important to note which color corresponds to which pinout on the joystick. Note that the pinouts are ground, followed by 5 volts, followed by the 2 analog outputs, followed by the switch. Connect the other 5 female to male wires as shown. If your female to male wires are stuck together, make sure on the ends that you separate out 2 of the wires as shown. Connect the 2 leftmost pins into the breadboard, making sure that they are in the same order as the pinout. Note that the far left is ground, followed by the 5 volt pin. Skip a column and connect the other 3 wires as shown. In the same way as before, partition out 2 wires for your ground and 5 volts, and your 3 on the right side. Make sure you keep the same colored order and connect the far 2 left pins as shown. Note that the grounds are connected together in column 25, and the 5 volt pins are connected together in column 26. As before, skip a column and connect the other 3 wires as shown in the same colored order as your pinout. Starting from column 25, this is an overhead view of what your wiring should look like. Next, grab 2 shorter wires. We will now connect the 5 volt and the ground lines to the power rail. Begin with a wire in column 24. This will represent the 5 volt line. Connect a second wire in column 25. This will end up connecting the grounds together. With that same wire, connect it to the minus or ground power rail, that is the lower power rail. Connect the right 5 volt line to the positive power rail, which is the upper power rail. We will now be connecting the analog outputs to the Arduino. Grab your 4 medium-sized male-to-male wires. Connect 1 wire as shown below in column 22. This will connect our VRX analog output to the Arduino. Connect another wire right next to it for VRY, which will also be another analog output. Connect the far left VRX analog output into A0, the Arduino analog input, and then connect the VRY analog output into Arduino's A1 analog input pin. Connect another wire to the VRX output of the second joystick. For me, this corresponds to my purple wire, but always double check the pinout of the joystick. Right beside it, connect another wire which will connect to the VRY output of the second joystick. Connect the left VRX output into the Arduino A2 analog input pin. If you want to pull off what Dr. Brooks would call a pro gamer move, replace your medium-sized VRY output wire with a longer wire as shown here, and you can wrap it around your other analog output wires for better cable management. As shown below, you can tie a little knot at the very end to make sure that your wires don't pull out. It'll look like this. We will now connect the switch outputs to the Arduino. These will signal when you press the joystick in on itself. Find the set of 3 wires connected to the breadboard, and the far right should be your switch output from the first joystick. Connect a wire to the same column as that wire. The same should be true for the other set of 3 wires. Verify that the right wire connects to the switch output of your second joystick. In that same column, we want to connect a second wire. Connect the right joystick switch output into digital pin 9. Secondly, connect the left joystick switch output into digital pin 10. Next, you want to grab 3 of your longest wires. For cable management, we will be twisting wires together. Hold one end as shown, and then twist the wires together. Hopefully at the end, make sure that you have 2 wires that are together and then one slightly separate, as shown. Grab your other 3 longest wires and do the exact same thing. Once again, one of our wires, which will be our signal pin, is separate, whereas the other 2, which will be our ground and our 5-volt pin, are together. Next, grab the rest of your shorter wires, you should have 6 left, and similarly to what we did before, twist them as shown. Once again, make sure that one end is sticking out while the other 2 are stuck together. If you completed the previous tutorial, you should have a fully calibrated robot arm ready to go. If you look at the wires from the robot in the extended position, you should see this nice cascading effect that corresponds to which servos are placed where. Note that this top servo is for the claw, this one right here is for the neck, this one is for the base arm and the neck arm, and this last one is for the base. We will be starting with the claw servo, which should be the highest placed wires. Grab one of your longer sets of wires and connect it to the claw servo. Note that my colors are very convenient, where my yellow corresponds to yellow, red corresponds to red, and brown corresponds to brown. But since your colors are likely going to be different, make sure you take a note of which colors are connected to what. Note that brown is ground, red is 5-volt, and yellow is the signal pin. Remember earlier that we set one of these wires aside and the other 2 were connected together? The ones that are connected together are the power and the ground pins. For those same set of wires, grab the 2 wires that are twisted together at the end, that should be your 5-volt and your ground wires, and connect them to the power rails. Make sure whatever color is connected to the red servo wire is connected to your positive power line, and vice versa, make sure whatever color is connected to your brown servo wire is connected to your ground. The other wire should be the signal pin. Verify that this connects to the yellow servo wire. We will be placing this in digital pin 2. Next, grab your second longest set of wires. We will now connect to the second highest wires, which should correspond to the neck arm servo. Connect the longest wires as shown, keeping in mind what colors you are connecting to. As shown before, connect the 5-volt line to the positive power rail and the ground line to the negative power rail, just like shown. Once again, verify that your signal wire is connected to the yellow servo wire. We will be connecting this into digital pin 3. Our next set of wires correspond to the servo that connects the base arm to the neck arm. As shown before, but this time using your smaller set of wires, connect to the servo. Where there is space on the power line, connect the 5-volt to the 5-volt and the ground to the ground. Connect your signal pin to digital pin 4. Finally, take your last set of small wires and connect it to the servo and the base. Once again, where there's space on the power line, connect your 5-volt to 5-volt and your ground to ground, pushing it in like so. Now place your final wire connecting to the yellow servo wire into digital pin 5. Before moving on, please make sure that all of the red servo wires connecting to the breadboard are connected to the positive power line and that all of the brown wires from the servos are connected to the negative power line. Making sure that you have the correct pinout ensures that you do not burn out one of your servos. It has been done before. Cat break! Congratulations! The wiring is now complete. We will now be learning how to upload the code into the robot arm. If you're watching this tutorial on YouTube, use the links in the description to get access to the files if you're a UF student. If not, you should find everything that you need in Slack. In the robot arm folder, you should see a file called ASME robotarmcode.ini. Hit the 3 dots in the upper right, hit download, and once it's finished downloading, click on the file to open it up in Arduino IDE. Assuming that you already have Arduino IDE, you should now see the full code for the ASME design project. Now, connect the Arduino to your computer using the wire in your kit. To show your computer where to find your Arduino, move your mouse to the very top of the screen where you will see the tools icon open. Click on that, hover your mouse over port, and now you should be able to click on the drop-down with Arduino Uno in parentheses. After you select the correct port, go to Tools again and click on Board, go to Arduino AVR Boards and select Arduino Uno. If you still do not see Arduino Uno, click on. Finally, if everything went smoothly, click the Upload button. It'll take about 5 seconds to upload the code, and once it does, you should get a similar message as shown below. If you're still having issues connecting to your Arduino Uno, try disconnecting and connecting the wire again to your computer and going back into your port settings and selecting the Arduino Uno from there. Finally, if everything is working correctly, you should now have a fully functioning robot arm. Grabbing the left joystick, if you press it all the way to the right, the claw should open. If you press it to the left, the claw should close. Pressing down makes the claw bend at the neck, and pressing up makes it flip all the way to the top. If you grab the right joystick and push it to the right, the robot arm will twist to the right. If you push it to the left, the robot arm will twist to the left. Pushing it up makes the robot arm go all the way up, and pushing it down makes the robot arm bend all the way down. Congratulations! You now have a finished robot arm project that you made from the ground up. We hope that you enjoyed this project as much as we enjoyed making it, and if you have any questions, comments, and concerns, please reach out to our operations officers on ASME Slack. As part of next steps, or if you want a fun little challenge, if you notice, we did not include the switch outputs of the joysticks inside of the code. Right now, even though that they're connected to pins 9 and 10, there's no functionality for those yet, so you could do a lot of fun stuff, like, for example, recording different positions of the robot arm and playing them back, waving at your family, or targeting your enemies. The sky's the limit, so now that you built this thing, have some fun. Now that you guys have some skills, I highly encourage you that you check out some of the design teams at UF, especially our ASME ones. We have Biodesign, Vex Robotics, IM3D, 3D printing, and now Lunabotics too. So if any of those sound interesting, talk to any one of our ASME officers and we would be happy to tell you about it. For the last and final time, go Gators!